Hey guys, this is for Math 261 Applied Calculus 1, and we did start the chain rule notes. We did the first page, we finished all the examples on the second page, looks like, but we did stop, and we did, okay, here it is. So I see on the third page, we are going to finish this k of x, that's going to take me some time. And I will also record the rest of the examples, example 3 and example 4, and that will be it for section 1.7. So let's do this one. K of x, we're trying to take the derivative. The direction got cut off, but we are still differentiating. You see right here, the direction is to differentiate, okay? So let's go take a look at our function. I'm going to write down what we are doing. We are, oopsie, that's too big. What's going on over here? We're trying to differentiate this k of x, and we need to recognize that this k of x is a compositional function. This is a function where we have the inside function, and the inside is x plus 5 divided by x minus 3. And the outside function, the big picture, is we are taking this to the 5th power. So we have to use the chain rule here. So let's go ahead and get started. So k prime of x is equal to, I'm going to go ahead and take the derivative of the big picture. How do you take the derivative of y equals x to the 5th power? What do? You bring down that 5, right? You use the power rule. So 5 comes down, you keep the x the same, and then the new power, 5 will go down to 4, right? So that's what we're going to do. We're going to just kind of treat this yellow chunk as just x and take the derivative of the outside part. So bring down that 5, bring down this 5, and keep everything inside exactly the same. Don't change anything inside. And then what is going to be the new power? 5 will go down to 4, right? Now that's not it. This is not it. We just did the outside function's derivative. Now we need to multiply this by the derivative of the inside part. So I'll go ahead and write this down. My plan is now to take the derivative of x plus 5 over x minus 3. Okay, so the red part is done. The red, what I wrote down in red, this is all done. Okay, so it's just going to wait while we now work with this quotient. You notice this is a quotient. So now we have to take the derivative of this quotient using the quotient rule, right? So let me go ahead and maybe just do the work over here. Let's go ahead and take the derivative of x plus 5 over x minus 3 using quotient rule. Okay, so when we are doing quotient rule, let me go ahead and write down what quotient rule is. If you have a quotient and you're taking the derivative of that, the denominator is going to be g squared, right? And the numerator is gf prime minus fg prime. So that's what we are doing to differentiate this. So let's identify everything. F is the function on the top, x plus 5. So if f is x plus 5, what's f prime? Derivative of x is simply 1, and derivative of 5 is just 0. So f prime is 1. What about g? G is the function in the bottom. X minus 3 is g, and g prime. Derivative of x is 1, and derivative of negative 3 is just 0. So I got all my pieces identified. I'm going to go ahead and use these 4 pieces to write the derivative or find the derivative of that quotient. All right, so I'm over here again. I guess I should label what this is. What I just found over here, guys, these are my quotient rule pieces. Okay, I will use these 4 pieces to do the quotient rule. All right, so back to the original problem. K prime of x is equal to, the first part that I wrote in red pen, that doesn't change, so it's just waiting there. So I just copied that down. Now you're ready to do the quotient rule. Let's do the quotient rule. This is going to get multiplied by derivative of this. Okay. We're going to have to draw a fraction. So the denominator is going to be g squared. Remember, we have to do g squared. And when g is x minus 3, the denominator is just x minus 3 squared. Okay? Now let's go to the numerator. What's on top of this quotient rule? We have to first start with g again. And g is x minus 3. Okay, what's next? I need f prime. F prime is 1. Oh, that's easy. 1. And the quotient rule says subtract minus sign. And let's go ahead and get the next piece, which is f. F is x plus 5. And we multiply this by what? G prime of 1. Guys, what I just did, this is called quotient rule. So we should not be doing chain rule problem if you are not completely comfortable with quotient rule or product rule. So if this part, what I just did was just way too much, you're like, oh no, what's going on? She's going too fast. I do want you to take some time, go back to 1.6, practice couple quotient rule and product rule problems, and let me know if you want to go over a couple problems together, okay? I'm going to go ahead and just keep this one exactly the same. But let's simplify this. Let's go ahead and simplify this little bit, okay? Let's go ahead and simplify that. And what's that going to give us? The numerator, well, I'll start with the denominator. Denominator is still x minus 3 squared. The numerator, if I'm focusing on this, I'm just distributing by 1, so that doesn't change anything. This is still distributing by 1, so that doesn't change anything. But the second term is getting subtracted. Second binomial is getting subtracted. So I'll just subtract, or I will distribute the negative to x plus 5. So what will we get? We will get x minus 3 minus x minus 5. We got one more line down. I may need more room. K prime of x equals. Guys, I'm going to do something a little funny over here. Okay, I hope what I'm about to do makes sense. I will go ahead and write x plus 5 over x minus 3. And I will put the fourth power on both of them. And I will not forget about that 5. I will put that up here. You notice what I did. I just rewrote this expression into that form. Okay, because it's the same thing, right? I think we're trying to simplify these two, multiply and actually write it as a single fraction. That's why I'm doing this. All right, the denominator is still x minus 3 squared. What about the numerator? What happened? X minus x will cancel out, leaving us with only negative 8. Let's put these together. Let's put these together. Okay, I want to multiply this fraction so that I can write it as a single fraction. All right, if you multiply the numerators, which is 5x plus 5 to the fourth power times negative 8, I will get negative 40 x plus 5 to the fourth power, right? Okay, 5 times negative 8 gave me negative 40. All right, let's go ahead and multiply the denominators. This times that. You see, the power is exactly, the base is exactly the same, x minus 3. The first one had 4, the second one had 2. So in total, this has 6. Now I want you to take a look at this part because we can even go further. The top has, actually, you know what? I don't think we can go on. I was thinking this base and that base is exactly the same. In fact, they are not the same, right? So I cannot go on. I cannot go on. This is where I must stop because I could not go on any further. You know, I keep thinking about how far your homework will ask you to go, but I don't think we can go any further than this. And I tried to, at this point we were done. At this point we were done finding the derivative. It's just a matter of using these algebra skills to simplify it all the way down. So I think this is probably as far how far your MyLab homework will want you to go. So that was one good example, but if you run into a similar one, if you want me to do that specific problem, just send me a link to that, okay? Now let me see. It's been about 10 minutes. I can maybe do this one. You know what? No. I'll go ahead and stop this video here. I'll let this one process and I will come back and go over example 3 in my second video.